To determine the appropriate transformer size for a factory, it's crucial to calculate the total electrical load, considering both current and future needs. The initial step involves assessing the present load. This includes summing the power consumption of all existing equipment. One needs to account for lighting such as metal halide lamps, office and storage area power requirements, the variable speed compressor, and the production line's power usage. If the air conditioning system's load is available, it must be included. For example, if there are 34 metal halide lamps, each consuming 1 kilowatt, that equates to 34 kilowatts for lighting. The office and storage areas drawing 250 amps at 220 volts translates to 55 kilowatts. Add to this the compressor's 75 kilowatts and the initial production line's 80 kilowatts. Now, for calculating future load, project the additional power that will be required when the factory is expanded. This includes the second production line, any robots, and the conveyor system. For the production line, the load is 80 kilowatts. Robots and the conveyor system are estimated at 50 kilowatts. All of these must be included. To find the total estimated load, combine both the present and future loads. If the present load is 482 kilowatts and the future load is 130 kilowatts, the total load comes to 612 kilowatts. A three-phase kilowatts-volt-ampere is computed using this formula, volts times amps times 1.73 divided by 1000. Assuming a voltage of 220 volts, then kilowatts-volt-ampere is 220 volts times 612 kilowatts times 1.73 divided by 1000. This equals to 248.7 kilowatts. Based on these calculations, a 250 kilowatts volt-ampere transformer would be suitable. It is important to remember that this transformer size is an estimate. Actual load requirements and equipment specifics may vary. Consulting with a qualified electrician will help to verify the transformer size and to design the electrical system complying with local codes and regulations.